Okay, this is another sample problem for solving absolute value inequalities. Absolute value of 3x minus 2 is greater than or equal to 5. And once again, I remember that if I'm given the absolute value of x is greater than some number b, I then know x has to be greater than b, and likewise, x has to be less than the opposite of b. Sometimes I like to write it b less than x2. All right, so I know that, so I've got my two equations. One equation is 3x minus 2 is greater than or equal to 5. And the other equation is 3x minus 2 is less than or equal to negative 5. And let's just solve these two equations. Let's start over here. 3x is less than negative 3. X is less than negative 1. So I like that. And in this equation, 3x is greater than or equal to 7, which means x is greater than or equal to 7/3 or 2 1/3, whichever way you want to look at that. So interval notation, number line notation, -1, 7/3. Okay, we know that it can be equal to or greater than, equal to or less than. So you've got negative infinity all the way up to -1 included, and from 7/3 all the way to positive infinity. And I'm going to graph this and convince myself. So I've got, just to make it easy to graph, I'm going to put everything on one side of the equation. So absolute value of 3x minus 2 minus 5. And I'm looking at the points where the points on the graph are all greater than 0 or greater than the line y equals 0. If I look at that graph, here it is. Notice that I've graphed y equals the absolute value of 3x minus 2 minus 5. And you see that where the graph intersects the x-axis, or the points where y equals 0, the output equals 0, are -1, and 2.333 is 7/3. And then the points on the graph where the output is greater than 0 are all of these points and all of these points. So we can see that that's all the way negative infinity to -1, and this is 7/3 all the way to infinity.